d is equal to the square root of x1 minus, or you can start with x1, you can start with x2, it doesn't matter. x1 minus x2 squared plus y1 minus y2 squared. Okay? Or you can write it out as, because the d is equal to both, it doesn't matter. Square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So you can write it out just like how you do the slope. You can write this out either way. All right? How this comes about, if you start with the x1, you must start with y1. Just like slope. If you start with x1, you must start with y1. If you start with x2, you must start with
y2.
There you go. Okay? Cool? What's up?
So like it doesn't matter what order we put them in, we're still making the same answer?
Yes, just like slope. Okay? But this is the only rule you have to follow. If you start with x1, you must start with y1. If you start with x2, you must start with y2. Okay?
Wait, why is it squared though?
Why is it squared? Well, that is I'm gonna be honest with you. That is a better question that I can answer for you when we start going over circles, because you will see this distance formula again. All right?
Yeah. Like the distance
So-
between the middle and whatever.
Yeah. So when we start going over circles,
Circumference and stuff.
and I show y'all the distance between the radius and the side of a circle, you're gonna see this formula again, and then that's when I'm gonna drive home the point of the square. All right? Because so anyway, let me see. Let's say the distance, I don't know, you might have this point right here. I'm just making these points up, by the way, so, you know, but it happens with every point. Also, this, with the distance formula, we are going to be examining simplifying radicals, okay? Who here knows how to simplify a radical? Show of hands. Great! We're gonna go over it.
No.
That's a word.
Simplifying a radical, yes. Okay, so first things first, let me just show you the distance formula, all right? So you might have, I don't know, -5 and 3 and 4 and 2, whatever, I don't know, right? So from looking at this, obviously, what I want y'all to do is label, of course, x1, y1, x2, y2, right? I want y'all to label. And you can pick either one that you would like. It doesn't matter, okay? So, D is equal to, let's say 4 minus a -5. We want to make it positive. Although, you know, it being squared, it's going to be positive anyway. So 4 minus a -5 squared plus 2 minus 3 squared, right? What happens when you're subtracting a negative?
You add it.
You add it, right? So square root of, what's 4 plus 5?
9.
9 squared plus 2 minus 3?
-1.
-1 squared, right? What's 9 squared?
81.
81 plus 1 equal to the square root of 82. Now, let's discuss radicals for a second, because y'all need to simplify. Okay? So, when simplifying radicals.
Oh.
Okay.
Simplifying.
You spelled that wrong.
This is math class, not English.
Huh. Huh.
It's okay, Mr. Control.
I know. Ah.
Yeah, I thought it was enough.
Yes, it is. Whatever. I'm math. I'm moving fast. My bad. How much time I got on this? I'm at 18. Okay, so simplifying radicals. First things first. Who can name for me a perfect square? Who here knows what perfect squares are?
Ah. 90, 90, 90.
I tried to think
Equal.
It's okay. Zukowski?
Basically, it's anything can be squared, isn't it?
So you're close. You're close.
Oh, I thought we were talking about square shapes.
Yes. So if I were to sit here and say 1 squared is equal to what? 1. 2 squared is equal to?
4.
Oh,
4.
that?
3 squared is equal to?
9.
9. 4 squared is equal to? And
25.
you know, all the way down to about like 9 squared is equal to 81, right?
What's 10 squared?
So, a perfect square. These are just regular squares. Now, on the flip side, you have their opposites, which are roots, okay? And the square root of 1 is 1. Square root. These are what you call perfect squares because it's when you do the square root of something and you come up with a whole number, not a decimal. So the square root of 4 is 2. Square root of 5.
3.5.
Oh, I'm sorry, not square root of 5, but square root of
25.
25.
Thanks for the answer.
Yeah. Square root of 25 is 5. You know, so on and so forth. Square root of 64 is
8.
8.
Oh.
There you go. So, you know what I'm saying?
Oh, so it's complete opposites.
Like I said.
That makes
By
sense.
itself, square root.
It's like division, kind of.
Yeah. So on and so forth. 84 divided by 8 is equal to 8. All right? 64 divided by 8 is equal to 8. Sorry.
Oh!
Ugh.
I put.
It's been a long weekend. So, anyway.
Wait, line.
So, these are perfect squares. And when you're simplifying radicals, okay, you have to ask yourself how many perfect squares go into this number. Okay? So, we look at this. Let me just back this up
Wait.
so that it can, yeah, I can write it over here. Okay, so you have the square root of 82, right? Square root of 82. And you're asking yourself, this is when we start to put the Christmas tree into effect. All right? So, yes, the Christmas tree.
Yes, when you said simplifying radicals, I forgot, but then when I saw it, I know how to do it.
Okay. So, great. So, you ask yourself, okay, obviously 1 times 82 is equal to 82. 2 times what is equal to 82?
41.
41. Thank you, Miss Burns. Does 3 go into 82?
No.
Anybody find out?
Nope.
Gotta go, man.
Oh my god.
No, it doesn't. What about 4?
No.
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 4 goes into 84. 5? No.
No.
6?
No.
6 goes into 72, but it doesn't necessarily go into 82. 7? Nope.
No.
Nah. No, it doesn't. 8? No. 9?
No.
Almost. 10, 11, 12?
No, no.
It's kind of
So,
Maybe
it's kind of up there. So, long story short, do we have any perfect squares that go into 82?
No.
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 If it was
So we can't necessarily.
81, it would.
Yeah, if it was 81, then yes. But we can't necessarily simplify it if we do, okay? So therefore, we're just gonna keep it as the square root of 82, okay?
Oh,
So that's the answer?
so
Yes.
unless, okay, yeah.
Unless
so
it's
you
able to be
just-
square
root,
root, keep it square root.
Yeah.
Hold on, I heard about 3 questions at once, what's up?
So basically, you gotta find what goes into it.
Mm-hmm.
Okay.
Oh, don't worry, I'll show you some more, okay? Let me just restart this camera. Okay, so for 9 through 12, you don't necessarily have to simplify. So we're not gonna, oh wait, no, wait. I see some simplifying.
Not mine.
Okay, so let me see. So for my number 9. Okay, so distance formula.
Oh, that's what we just did.
Yep, uh-huh.
So, oh.
So, for instance, let me see, you might have something that looks like this. 3, -7, and 5, and 5, okay? You might have something that looks like that, and you're looking at it, so you have obviously x1, y1, x2, y2, okay? Good? 3 minus 5 squared plus -7 minus 5